class. This is my math lab question, the one that has to do with a hemisphere tank. And so what we're doing is we're filling in water. Okay, so the question here is saying that the radius of this water tank is 9. So that radius is a constant. That's not going to change, right? So when you're looking at related rates problems, you're looking to see what variable changes and then which variable is a constant. So in this case, the radius of the water tank is a constant. It's 9. I mean, the tank isn't shrinking or enlarging, right? So the tank is the tank, and the radius is always 9. So the first thing that you should be thinking in this problem is when they give you the volume equals to this right here, you would say, okay, so R is 9. So the volume really is, the equation that we're working with is pi h squared times 27 minus h, all divided by 3. Okay, and 27 because R is 9. Okay, so if so just leave it as that, and then you would think, okay, now the height, which is the water level, is rising as the volume is increasing. Okay, so H and V are variables that change, and the rate at which they are changing are relating to one another. So basically, dH dt and dV dt are relating to one another. So those are the two variables you're working with. Okay, now the question is also saying the inflow, which is the rate at which the water is entering. So when the water comes in, what's changing? This right here, meter cube per minute, cubic unit denotes volume. So this is the rate at which the volume is changing, and minute is with respect to time. So the 4 meter cube per minute is dV dt. Okay, so the question is asking then, what is dH dt when the water was already at 8 meter? Okay, when H is 8 already. So that's what the question is posing, right? So in order to find dH dt given dV dt and an H value, we would go ahead and take the derivative of this equation here. But before we take the derivative, it would be good for us to go ahead and distribute and clean this up. So when we distribute here, 27 divided by 3 is 9, so that would be 9 pi h squared minus pi over 3h to the third power. Okay, so that is the equation that we're working with. We now then are going to take the derivative of both sides with respect to t. Okay, so then we would have dV dt is equal to 18 pi h dH dt, that's implicit differentiation, minus pi h squared dH dt. What are we looking for? We are looking for dH dt when h is 8 and dV dt is 4. Okay, so now we can do a substitution into this equation and solve. So dV dt, which is 4, is equal to 18 pi when h is 8. Okay, and then dH dt minus pi times 8 square dh dt. And we know that we have to factor out dh dt. So 4 is equal to dh dt. Factor that out. We would have, what is 8 multiplied by 18? 8 times 10 is 80. 8 times 8 is 64. And you will have 144. So that would be 144 pi minus 8 squared is 64. So that would be 64 pi. And then, so this would be dh dt is equal to 4. And in order to solve for dh dt, you have to divide by whatever this is. And so what is that? That would be pi. 4 minus 4 is 0. 14 minus 6 is 8. So that is 80 pi. So you're going to divide that by 80 pi. And that is the rate at which dh dt is rising. And if you want to, you can go ahead and get a decimal approximation if you would like. Okay, so I think in my math lab, it will ask you to get a decimal approximation. And we're talking about dh dt, and h is being measured in meter, right? And t is being measured in minute. So the unit that you have here is dh dt is equal to 4 over 80 pi meter per minute. And that is it. So I think the main thing here is when you are looking at the problem, you would have to think, okay, what is given to me? How do I know what that is? Well, look at the unit. The unit is going to give you the clue on what it is. Meter cube per minute. Well, cube measure volume. That is the change in volume over the change in time. That is dV dt. Okay, now the question is asking how fast is the water level rising? So it's asking for dH dt. When what? When h is 8. And then this problem actually gives you an equation to work with. Okay, now the equation has r in it, but we know r as defined by this equation that they give you, the radius r is the radius of the tank, which is 9. That's not going to change. So we can go ahead and plug in 9 right here. And this is the equation that we're going to work with, right? And then you can proceed from there. So yeah, when you see these problems, you need to understand what are the constants. The constants in this case would be r is 9. That's not going to change. And the things that are changing and that are relating to one another is the volume and the height of the water level.